Okay, everyone is very quiet. We can do MATLAB too. Let me show you the MATLAB. I think some of you are familiar with MATLAB. Huh? And let me try to run this. Oh, line 15. Require statistics and machine learning toolbox. Oh, how do I install them? Anyone knows that? How may I install toolbox? It needs statistics and machine learning. So sign in to install. Oh, how do I know what my account is? Oh dear, this is going to be difficult. Oh, I cannot remember the password, so I better stick with Python. Yes. Okay, this program is going to implement the, I believe it's MMck, MMck, hopefully. Okay, I think the best way is to learn together, not just me talking. May I ask each one of you to explain, the code together? Okay, who should begin? Who would like to begin? Shall we take turn? Who want to go first for line number 4? Can you speak? Who want to start first?
Yes, Professor.
Okay, please explain.
Professor, in the start, it's defined as the lambda arrival rate, that is 1/4.
So compared to the departure rate, the departure rate is what? Smaller, right?
Yes, smaller.
So there are more arrivals than departure, right?
Yes, Professor.
Arrival are more often than departure, but we have more than one server. We can have more than one server. And row is defined as, correct or not? Row is the arrival to departure.
Yeah, lambda by mu.
Okay, and then the mean inter-arrival time is equal to 1/arrival rate. Is it okay?
It is the effective arrival rate, or what we can say?
It is the same. It's the mean arrival rate. Can you see?
Oh.
If you have, I mean, 2 people arriving per hour, so what is the mean inter-arrival time? 30 minutes, right? Or 0.5 hour. If you have arrival rate, yeah, they have arrival rate equal to two person per hour. 2%. So you have one person every 30 minutes, right? Agree or not? If you say you have people enter the room, 2 people per hour, then the mean inter-arrival time between 2 persons is half an hour. Does it make sense or not?
Professor, right now in this case, it would be, I think so, mean arrival time would be 4.
Yes, the arrival time will be 4. Yes. So it takes
4 seconds. It would be 4 seconds.
Any unit are okay. You can adopt second, minute, or hours. It will work the same way. If you treat this as second, then 4 seconds. And then the arrival rate will be 1/4 arrivals per second. You must use the same unit. And okay, you got it, right? You have no issue with this, and okay, can you continue then? How many customer we are testing?
Then in this case, we have defined about 100,000 customers.
Okay, we are gonna
and
test
the
people.
server is 1, and the maximum capacity that is C.
Yeah. If you have one server here, the system will overflow, right? Because departure is very slow compared to arrival.
Yes, Professor.
And this will become, more people accumulated into the system. Unless you put more servers in, but this is just an example. And the maximum capacity. So this is a MMck, I suppose. Okay, C equal to 1, K equal to 3. So how many waiting space? 2. Okay. Maximum capacity 3, which includes the server. So you have two queue, two waiting space. And what is the queue limit? Queue limit is max capacity. Okay. Are you okay with this?
Yes, Professor.
Okay. Remaining queue size, possibly tracking, how many space in the queue has been occupied. So we just
Professor, in this case, I think so. What I think is that because it's MMck, so we initialize the queue with the 0. However, it would increase randomly as the customers arrive.
Yes. I'm not sure why remaining queue size should be 0, because it should be queue limit, right? Because no customer. Maybe later they set them to the proper value. Okay. So starting with system time equal to 0, and this is number of arrival customers. So we are keep track, counting the number of arrivals, counting the number of departures. How many users have been blocked? Yeah, because MMck means blocking system. And we are all waiting time. Let's start. First step. Who would like to explain this? Next. สืบพงษ์ได้ไหมสืบพงษ์
ดีนะครับดี
Yes, I can hear you, but can you explain what this is doing?
Not actually. let's say
I can print it out and then you can
Yeah.
say what we are referring to.
okay.
And then okay, that is the that is what happened. If I add 2 servers, 3 servers,
That would be two more of the math.
okay. So we
Yeah.
are initializing
The time next
next
event.
event
Yeah.
for the server, right? For the server needs to know, what is coming to them. So you have to create as many as the servers. So I delete this, or I can keep them, no problem. And then the server status, we set them to what?
Yeah, it's also one.
What did we set them to?
Server status.
Okay. Server status. Yeah.
That the zero stand for.
Yeah. We initialize them to 0, right?
Yeah.
That means the server is
Down
idle, not occupied. And arrival time to queue. So we print it. Print the arrival time to queue. And what is the arrival time to queue? What is the arrival time to queue? Queue limit. Queue limit is at the moment there is no queue, right? Because capacity 3, server 3, no queue.
No one
If we make the capacity bigger, then you will have 2 queue to work with, okay? And this is a time when the events have to be scheduled in the queue. Okay, and then we print again. What's happening? This one is the queue, right? The queue, and time next event. Why you print arrival time to queue twice? We print this better. Queue status. So queue status is, what is the status? Nothing in the queue, okay? Okay, now let me summarize again. First one, time next event is infinity. Time next event. Time next event means the event to the server. And then server status is idle. Arrival time to queue. No arrival. Queue status, empty queue. And then time next event. Time next event, we generate random variate. Time next event plus we add them. It seems we added at the last component. Yeah, because we add them to this time next event. And then now the simulation begins. Tan, would you like to help? Tan. Yeah.
I think I should give a change to another action.
Make what? You mean the font size or what?
I think I should give the change to the everyone else to explain it so they can understand code.
Send the what? Chain. Yes. You mean you what do you mean? I'm not quite sure what you mean. Oh, give chance to everyone else. Okay. Okay, who would like to do this? Who would like to do the next one? รักดีไหวไหมรักดี
ได้นิดหน่อยค่ะ
ได้ไหมโอเค
เดี๋ยว
so
ลองดูก็ได้ค่ะ
ลองดูนะโอเคTang if she cannot do it you can help okay
Yes,
okay okay รักดี we are going to perform this loop ถูกไหมครับ we're going to perform this loop
ค่ะ
and then when will we stop the simulation based on this condition when will the simulation end เมื่อไหร่ simulation จะหยุดฮะ when we set maximum number of customer to 100,000 okay and we use number of departure customer to keep track of how many customer have left or departed the system ใช่ไหม so simulation will run until you have 100,000 people leave the system ถูกไหมครับ
ค่ะ
มันจะต้องนับให้คนออกไปให้ได้ 100,000 คนแล้วมันก็จะหยุดนะ I think it's too long นะso gonna run just 10 customers then as soon as 10 customers have left the system then we stop the program make sense or not everyone โอเคไหมรักดีเคลียร์ไหม
ก็คือหมายถึงว่ามันจะหยุดรันตอนที่
ยังไง
อ๋อ
นะ
หมายถึงว่ามันจะรันไปเรื่อยๆในขณะที่ยังแบบว่ายังน้อยกว่าจำนวนลูกค้า
ใช่จำนวนลูกค้าที่ออกจากระบบ as long as the number of customer that departed the system is smaller than 10 the program continue to run โอเคไหม
โอเคค่ะ
Okay let me run I don't know whether it works or not but yeah it runs นะwho next then who next who would like to come next สุภชาติ are you okay with this command สุภชาติ are you there คนอื่นไหมพีรยุครับ
ครับ
ลองดูไหมลองดูลองอธิบายฟังtime next event I think we have printed them here
เป็น
right
infinity แล้ว 9.7 ใช่ไหมครับ
correct so the minimum value of this will be
ก็คือ 9.7
yes we are taking the minimum time minimum time we consider the time that happens first and then what happened then this time it will be 9.7 เอาอีกบรรทัดได้ไหม
เราสร้างตัวแปร event type ขึ้นมาจากตำแหน่งของtime ที่น้อยที่สุดครับ
Okay
เก็บไว้คือตัวแปร event type
Okay excellent so it is talking about 0 1 2 3 okay so this event type will be 3 agree นะ okay Then we advance the system time, you know, to this time directly. I'm not sure if you agree with me. Let me print it out and see. I don't think we need all this, so I will delete them. Now this is just initialization. Okay, let's run. Okay. You can see that we start you know, time next event. This is the key to the simulation. It keeps time for server number 1, number 2, number 3, and the arrival. This is the arrival. And then it brings time, system time. As you can see, system time is updated to 0.814. Here, can you see system time? Because this value is the minimum value of all this. And the event type is 3. 3 refer to arrival. 3 refer. That is what we agree upon. If you have 4 servers, then the event type will be 4. Can you see? Basically, it is the last event in this event list. It's the last one. We assign them as the arrival time, and then they print end. Okay, so this is the arrival time. The arrival time. Then we check if event type equal to number of server, which is 4. So it means it is the arrival event. Else will be the departure event. Are you clear with this? Clear, man? Clear you?
ครับ
There's nothing you know, difficult about it. ปิยภูมิไหวไหมปิยภูมิไม่อยู่นะก็มีสุภชาติokay, who else who would like to try? Ali, are you ready to try this command?
Yes, sir, I am.
Yeah, what is this command then?
Sir, we are actually discussing the no arrival customer, I guess. P0 is something with that.
Because the next event is the arrival, right?
Yes, sir.
So we're gonna keep track of how many arrival customers. Just add 1 to it, because
Exactly, sir.
yeah. And then what we do with it then? Next command. Okay, one more command. The time next event for the arrival must be updated, right? Because
Yes, sir.
this is the time. So we are trying to find what is the next arrival. So you start with the current system time plus random, right? With the arrival rate. And so it will generate the inter arrival time for you for this command. Then you keep them into the time next event. Okay, are we okay with this?
Yes, sir.
And then yeah, I mean, if you want to see that it is arrival, you can leave it out, or the departure. Let me try first. Okay, we see that the first arrival come at 1.2 seconds, 1.29 seconds. It is event number 4. We definitely know that it is arrival. Other than that, it is departure. Departure from server 1, departure from server 3, departure from server 0. Can you see? I hope you follow a bit. And And what is next? Now let's consider the arrival time. Next event already set up. Number of server busy. What are we doing here? ใครช่วยได้บ้าง Who would like to try? อัครพันธ์ไหวไหมอัครพันธ์
Professor, I want to ask that do we have to check the busyness of the server? However, we defined that the servers are, I think so, there are, I think so, 2 servers we defined initially.
Yeah, in this case we set 4 servers, okay, and then how many queues? You can have only 1 queue, right? Yeah, because
Professor, 4 servers means we can have randomly 4 queues, isn't it?
you can service 4 customers at the same time. That's what it means by 4 servers. And max capacity include number of server and the queue size. So there is only 1 queue here for people to wait. So 5 is the capacity of the system. If there are 5 customers in the system at any time, then new arrival will be rejected. Out of these 5 capacities, there are 4 of them can service you, but the last one is for you just to wait. Make sense? So now you are.
Professor, I want to again ask that we have 4 servers. Means we can have the 4 queues, mean the 4 servers can at the same time handle the 4 customers. Okay.
Right, correct. And then,
so you want to say that the 5th one would be in the waiting list or rejected?
Yes, in the waiting list. So you have one waiting space, one waiting place.
Can you also tell us please that how much the waiting queue we can define, how much limit of the waiting queue would be?
Anything. If you set it to 10, then you have 6 people in the waiting list. You can have up to 6 people in the waiting list, right?
Okay, understood, Professor. Understood.
This is very flexible. This is actually the assignment that I asked you to do. But anyway, we just keep learning first. Okay, so I keep this. I can put it back to. Shall I make it 3 servers and 5 capacities? So 2 waiting, 2 can be waiting. Now, as you can see, we check how many servers are busy. Because server status are initially set to 0, it means they are idle. If they are occupied, then the server status will return to 1. So we simply sum them, and we have 3 servers. So maximum number of server busy is 3. Okay, only 3. In this case, number of server busy is 0, right? Because server have not been, used by the customers. So we can print it out to see what happened. Starting with the initialization here, we know that the first arrival come at 9.9. And as the time move to 9.9, we also know that this is the arrival. And then we generate the next arrival to 14. And number of, what is it? Number of server busy is 0. Okay. Of course, if the number of busy is less than the number of servers, it means the customer will be services immediately. Otherwise, it means all server busy. All server busy. So you will be put in a queue. Okay. This part tell you that you will be put in the queue. And here the server are available. Then you just go through the server one by one and check if the server status is available. If yes, we pick that server to treat the customers and turn them into a busy status. And then we generate the time where that customer will leave the system. So random variate with the departure rate. And then all waiting time append to 0. We actually collecting the waiting time of every customers. In this case, you come in and you get the service right away. So the waiting time is 0. So we append 0. Now this is the case where all server has been fully occupied. So you look at the remaining queue size, which is the queue limit subtracted by the queue status, sum of the queue status. So actually this remaining is not needed to be defined. Yeah, well, let's see. And then we check, okay, there are some space for you to wait greater than 0. Then we go through the queue, the waiting queue one by one. Whichever queue that is free, we add that customer to the queue. And the way that we add them into the queue is to record the current system time. So we know what time that this current customer arrives. Then queue status equal to 1. Now that this particular queue, waiting queue, is busy now. Then we break. Now if the remaining queue, no waiting remains, it means you will be blocked. So we just say number of blocked user is +1. And this program has handled the arrival events, fully. Now for the departure, if it's a departure event, we are counting, one more departure customers. Server status that treating this current customer will now be set to 0, meaning it is available now. The server is free. Then we say, okay, time next event for the current server is infinity. Yeah, that this is a standard procedure when a customer is leaving a queue. Now the number in the queue. Now since the server is free, it then check whether anyone waiting, and that's what we're doing here. How many people waiting in the queue? Yeah, if it's greater than 0, then when someone needs services, we pick the one that arrived, first, the first arrival. Then we look for the index of at first arrival. Then if that queue equal to 1, it's supposed to be 1. It's supposed to be 1 because that's what we set it. The arrival time, you take it from the arrival time to queue with that index. If the arrival time not equal to first arrival, the first arrival is the time that we measure, then something wrong. We're just performing error checking. And all waiting time append. The waiting time is this is system time. subtracted by their arrival time. Now that is a waiting time. Time next event will be the departure time. So we set the departure time for this server. Then the server status is busy now. Server is busy, and the queue become free. And because we move customer from the queue to the server, server become busy, and the queue become empty. Arrival to the queue also have to initialize to infinity. Then if the queue status is 0, then something wrong. That's it. The program is done. The rest of them are calculating the blocking probability. Mean waiting time, you sum all the waiting time divided by the number of arrival, and number of user block, and so on. And then you compare to the okay. I will send you this program now. Let me save. Okay. Okay, I have sent. Can you test the program whether it works? Let's say set the customer to larger number and not to print, because it will take time. Okay, and then run, and it's finished. It shows that simulation is 3.2. The Erlang B. This is Erlang B. This is MM1K. Okay, I think we can compare to Erlang B if we put it like this. Simulation blocking, almost similar to the Erlang B formula. Okay, make sense? So what are we going to do next then? I think I can show you how to verify. For example, if we want to test at 1% blocking, okay, maybe at this 2.5, 7 servers, okay, 7 servers, and the Erlang is 2.5, blocking is 1%. So we set number of server to 7, yes, and then the Erlang is 2.5, so it's very simple. We just set 2.5 for lambda and set 1 to the departure. Now, if we run the program and it gives us 0.01 blocking, then it's working. 0.1, sorry, 0.1. Based on Erlang B, you get 0.0099, and the simulation give you 0.01. So it matches. Are you okay with this?
Professor, can you explain the terms that are mentioned in the sheet, that is N and B%?
N is number of servers. Now let's make it 10. Can I make it 10 servers? So I go with the 10 servers. I'm simulating, 1 million customer, which is a lot. And the traffic is 4.46. So I turn this to 4.46. And departure rate 1 for, it's simple, put it this way, simple. Okay, and the blocking is 1%. Can you see? This is simulation. This is analytical model. Are we clear with this? I mean,
So from this sheet, we get the number of servers and the arrival traffic rate means the arrival rate.
Yeah, the traffic in Erlang.
Traffic in Erlang, which is basically the arrival rate. Okay.
Not exactly arrival rate per departure rate. If I double this, become 92, 892, and I turn departure rate to 2. Same traffic, right? Same traffic as the one I said before. And I should.
It is the ratio of the second index in the tuple of the formula of Erlang B, right?
Yeah. It's a ratio. It's an arrival rate per departure rate, and you can see you get same thing. Blocking, same thing. You can turn arrival rate to 89.2 and departure you have to 10 times more. Same answer will be obtained. Yeah.
I have a little confused why the number of server and the max capacity has to be the same.
Because we are testing MMCC queuing model, where you can apply Erlang B formula. Yes. This is a specific case, but it's good, easy testing. Now, suppose, okay, I think let me do this now. I'm gonna keep it 4246 so that it's easy to see. Okay, I should get 1% of blocking from the simulation. Here 1%, almost 1%. Okay. All right. Now we can learn what happens if we add one more space for waiting, one more space for waiting, and see whether we can improve the blocking. Should it improve? Should the blocking probability improve? You can see from here that it has improved a lot, from 1% to 0.4%. If you add one more capacity and see what happened. Blocking is coming down. Can you see blocking is coming down? Yes. If you put more queue into the system, it will help reduce the blocking probability. Well, it makes sense. You come into system, all the servers are occupied. If you don't have any space to wait, then you go home. You see, we are lowering the blocking.
So professor, it means that by increasing the blocking, by increasing the waiting queue, our blocking probability is getting low. Means the more customers are getting facilitated.
Yeah, they are being treated. Not getting the service immediately, but at least they can sit in the waiting room, right?
But professor, here are many trade-offs that rather than increasing or decreasing the arrival or departure rate, we can just vary the queue size also to decrease the blocking probability.
Yeah. You are running a business and you have same customers, right? Let's say you have same traffic, same customers. What you can do is hiring new server, or just creating a new space, a waiting room. It helps improve your revenue. So now it is a good time that you use this software to solve the problems in the paper, in the assignment too. For example, I think I received a, yeah, you can do this one also, you know, MM12, right? MM12. Yeah, can we use this simulator to answer question 6 or question 5? Shall we try use simulator to solve this problem? We have MM12, no problem. The simulator will run. And then every customer that accept to the system give you $5. So we have how many? We are testing 1 million customers. So we multiply by 5. That is our revenue. Okay, profit, our profit. Each customer rejected result in a loss of $1. So let's try this one. MM12, number of server is 1, capacity is 2, right? And they are asking you to, we are able to calculate the profit easily because we can use the number of departures multiplied by 5 and then rejected. Have we measured rejected customers? Do we measure the number of, number block? Can you see? Number block. So in that case, that easy now. After the simulation done, we just print our profit, okay, which is equal to 5 times what? 5 times of what? I can treat the number of departure, I suppose. Which one is better? It doesn't matter. I mean, it's little difference. And then you can print the loss. The loss is $1 times number of rejected. Where is the number of rejected?
Is number user block.
And then that's done. Don't you think that hopefully our problem is solved? What they ask you is to search for what? Search for what? For break even. Find the arrival rate for break even. So we probably have to assume that departure is 1, which I keep it like 1. Oh, is it printed, right? You have profit of this and you have loss of this. This is not break even because of what? You have more profit than loss. So what can we do? You have more profit than loss. So I increase the traffic to 10 and make it extreme. Too much traffic, probably many blocking also. So we have tested, and now you have more loss than profit. Can you see? We were testing with 10. With 10. 10 is on one side. Okay, I will split between two sides. So we can try, what can we try? 7. Now we are trying 7. And would it be on the loss or on the, yeah, we are losing, yeah. So 7 is on this side. It has to be lower. 6 then. 6 then. 6 then you still losing. So we have to lower to 5. And now you are benefiting. So 5 is on the left hand side. Okay, so probably 5.2. And you're still winning at 0.2 still winning. So maybe 5.76, 5.6. You still winning? Oh, 5.9. Oh, I didn't change the number. Sorry about that. 5.6. 5.6. Yeah, we're making profit, so I make it 5.9 then. 5.9. Okay, so 5.9, you're losing a bit. 5.9. So probably 5.8. Oh, no. 5.8. You know what we're doing. And now,
try to find the breakpoint.
yeah, we are now still, getting profit. So you can take more customer. 5.85. 5.85. Yeah. Of course, you can do the analytic approach, but this is to show you that simulation can be very useful too. So 5.89 is still making profit nearly now, no? Okay. How about 8? 5.88. Anyone solve this problem in the exercise, in the assignment? Now this one is 5.88. It's going to the other direction now. 5.8.
Try 5.854 maybe.
5.854. Okay. Yes, very near. Huh? Very near. We are making profit. We can increase it by 6. If 6 not okay, then 5 will be, yeah, then 5. Huh? If 5 not okay, then 4 something. Okay, I think you are getting the correct answer. Huh? 5.854 something. Yeah. No. my mistake. Mhm. Okay, let me know what you need me to explain. I think this is probably the closest answer we getting now. Anyone did this problem? And please confirm if you have this 5.85, 5.85. Tan, did you do this problem?
Yes, Ajahn.
Did you get 5.85, something like this?
Yes, the same, Ajahn.
Huh?
Yes, I have the same.
Oh, you mean using analytical, right?
Yes, Ajahn.
Oh, good. Okay. So the simulator seems okay. Everyone agree or not?
Yes, your code is working well.
So now this is the what is it? MMck program, nah? How do I add a file? Upload a file, choose the file, and then okay. Maybe it's good for you to try. Okay, I publish it. Okay, in case you need them, they will be available. Can you use this software to run for number 5? Okay. Everyone? Gentlemen, okay. To run the software and find the answer for number 5.
Let us try.
Okay.
Maybe.
Yeah. Good. Okay. Okay. Then you can ask question. Yeah. Anyone? Okay, they are buying 2 machines. One of them is with the mill and cost $B to operate. Machine 2 is 2 mil. 2 mil and 2B, isn't it? Transaction Poisson, lambda. The total is plus cost. This is total cost. $A. $8. For waiting, right? Each hour of customer have to wait. And expression for total cost per hour for each of the system. And then, okay, in our simulation approach, we are finding the total cost first. Finding the total cost. What the cost versus arrival rate? Okay, arrival rate is changing. So save as MCK thing. Let's say the arrival rate is lambda, so nothing changed. Departure rate is B. Let's say B equal to 1. Then the departure rate is 1. B is 1. So waiting time. Do we measure waiting time? Yeah, we do. So
in the variable or waiting time.
all waiting time. With all waiting time. In the departure or in the departure, I suppose. Okay. You have the cost for all waiting time, we sum them, can we sum them? The waiting time has to wait each hour, so $a. Then we multiply by $a. This is the cost. Cost for waiting. Cost for waiting is this amount, and
Also cost for transaction.
and then the cost. What is the cost for transaction? $B to operate. So it is the server, isn't it? The server, right? The time that server are occupied. Yeah? The time that the user, the server occupied. How do we find them? How do we find them? How do we find them? This one is for MM1, so server status. We need to write, additional programs. Do we? Tan, do we need to write additional program? ต้องเขียนเพิ่มไหม Tan
กำลังดูโค้ดอยู่ครับว่ามีแล้วหรือยัง
Tan, do we need to do we need to write additional programs to measure the time that server are occupied or not?
I don't think so, Ajahn.
We don't,
Yes.
so how can we know the operational time?
Yes, the shift time, Ajahn. The shift time will be the final one that final one in the time next event, right? You have arrival time, departure time, and the shift time will be the final when you finish the loop, the system time will be the final departure, right?
So you are saying that we just use departure time.
No, when you loop finish, you check your shift time. It's the operational time, Ajahn.
Operational time means, what does operational time means? Is it the time that server are occupied?
Yes, the operational time will be the time that the last customer departure, right, Ajahn?
They say that it costs $B to operate, but the
Yes.
machine are not running all the time, right? Machine will start and then stop and start again and then stop, depending on the arrival. So we're gonna have to know, you know, within this total time, how often the machine is running, you know, how many hours the machine running. That is what we need to measure. Don't
Yes,
you
Ajahn.
agree or not? Huh?
Yes, Ajahn.
So we still need a few lines of code, perhaps.
Yes, of course.
Yeah. So in this regard, I am going to set you the assignment to give you 10 points as the what is this Q? Q is a problem, right? Okay, I'm adding the fourth. By the way, are you ready to take the Cisco exam next week? You think you can prepare for next week? Anyone has other idea? Okay, so
Sir, are we talking about the Cisco final exam?
yes, the Cisco final exam. Can we have the next week? Can we schedule to next week?
We have to do it in the same time.
Yes,
Together.
definitely. It will be, I think, 2-hour sessions.
And so Zoom and share screen or something like other test in the other subject.
It will be the, what is it? The similar to what you have done so far. And okay, let me finalize this. I'm gonna give you a project that to enhance this program, the existing program you have, so that you can measure, you know, any parameters you are interested in and display them on the screen, you know, like a plotting a graph, basically plotting a graph.
Sorry, Ajahn, I mean the Cisco test.
Yeah. I will talk about Cisco later. Okay. Yeah.
Okay.
Let me finish this. How about for the 3D modeling? You asked for extension, so it was scheduled to 24th. And usually our assignment will last for 2 weeks, so it will finish at about 31st. Is it okay? Or it's too far? You prefer
Sir, Blender assignment or this one?
this one, the Python. Now I will set it to 31st first, and then what we would like you to do is, based on the MMCK program we did in class, please add, some codes, some necessary code to plot, graphs. For example, because it's a MMCK, yeah. For example, something like this. The arrival, number of arrivals as a function of time. The departures, let me put it in.
อาจารย์คะสไลด์นี้อยู่ในคอร์สฟิลไหมคะทำไมไม่เห็น
อยู่ครับผม The slide is in the my course view. Can you check? Based on the MMCK program we did in class, please add some necessary to plot graphs, including first arrival, right? Second, departure. Anything else you think that need to be plotted? Server occupation time, server status. So if you have two servers, you plot two graphs. Okay. Status of server, right? Of course, you also want to see status of the queue, right? Whether the queues are occupied or not occupied. What else you might want to display? 5. Number of customer in the system. Okay, anything else? Okay, this anything else you recommend it, student, choose his or her own, what the parameters to plot. Okay, reasonable or not? Everyone, reasonable or not? You plot this. เจอไหมเจอสไลด์ไหมเจอสไลด์ใน My Course View ไหมนี่เฮ้ยไม่มีใช่ไหมไม่มีจริงนะโอเค Okay, I have to add the material. Okay. Upload a file. Okay, ลองดูว่าไปไหมDo you have any concern with the fourth assignment? By the way, all that you have submitted, will be orally examined individually. So make sure you did not just copy and submit. you know what you are doing. All right. And once when you manage to plot them, you will be able to how to say. I think I think one more thing that you might want to plot is how about waiting time? What do you think? Is waiting time a good thing to plot? We already have plot the status of the server. How about the yes? How about the what is it? Time spent in the system. Okay, let me keep time a customer spend in the system, and then the time customer wait in the queue. Okay, I think this will be nice. I mean, if you can draw them the like a line somehow. So you are quite free. You are free to choose the plotting format. That helps understand the queue behavior. Okay, I think you can plot the block customer too, right? Number of block, right? Number of block customer. And then you are free to choose one of parameter you might be interested. Save. ได้ไฟล์แล้วใช่ไหมได้ไฟล์แล้วใช่ไหมเมื่อกี้ใครถามไอ้ไฟล์ Q
ไฟล์สไลด์เหรอคะ
ใช่
อ๋อ ได้แล้วค่ะ
Are these achievable or not? Are this assignment achievable? Okay, next Friday, we have this Cisco exam. Any question? It should last for 2 hours.
Do we have to doing by and open the camera right or the subject test?
Of course, it is individual exam. Let me ask อาจารย์ชัยวัฒน์ฮัลโหลอาจารย์จะเข้ามาหน่อยไหมอาจารย์จะเข้ามาประกาศเรื่องสอบไหมตกลงสอบกี่ชั่วโมง2 ชั่วโมงนะ3 ชั่วโมงเหรอวิชาละชั่วโมงทีนี้อาจารย์มาสรุปให้เขาหน่อยไหมก่อนที่เขาจะสอบจะได้เตรียมตัวได้ from อาจารย์ชัยวัฒน์ not many people have done the packet tracer part แล้วไงต่อดีโอเคอาจารย์เข้ามาหน่อยไหมเข้ามาหน่อยไหมสะดวกไหมเหรอโอ้เป็นเลือกตั้งเหรออาจารย์ไปสมัครอ๋อโอเคโอเคงั้นก็ถ้าติวเตอร์มันก็ต้องไม่รู้สุขภาพเป็นไงก็มีเทงอีกคนหนึ่งเทงก็ได้โอเคโอเคก็เป็นสอบกี่ชั่วโมงนะสอบโอเคโอเคขอบคุณครับเดี๋ยวผมจัดการให้2 ตัวคืออะไรบ้างคือการ practice final packet tracer โอเคใช่ใช่โอเคโอเคได้เดี๋ยวผมลองถามเด็กก่อนนะครับว่าทันไหมโอเคครับโอเคthe exam will last 3 hours นะ and involve the packet tracer that not many students how to say have done it so I'm asking you whether 1 week of preparation are enough and we will arrange a training that go through this these exercises with you. Okay, first question, will you be ready for next week? ทันไหมสัปดาห์หน้าสอบได้ไหมทันไหมครับฮัลโหล
สอบเวลาเรียนนี้เลยใช่ไหมคะ
ใช่ on the lecture hour but we can organize a training to make sure that you will be able to do it and okay let's help each other to do to get the graph to get the graph suppose we want to plot the arrival curve so we have all the arrival time then all the arrival time set it as an empty and then every time there is a new arrival what do we just keep them isn't it oh, where is the arrival time it has to do with the arrival rate for sure oh here I couldn't find it this one is arrival event as soon as you generate an arrival event find next 1 2 2 just two places that have arrival this is the first part so we append time next event correct or not
Ajahn, please share your screen, Ajahn.
oh sorry I didn't know that Because it has a system time plus well, we have to append. I mean, we append only the last component, right? The last component, which is -1. Okay, that is one way, one location, and we generate again when we are here, and again time next event. I think we can put -1 also, right? No difference, huh? And then almost the job done. We okay, we can run and see what happened. Append, no attribute. What did I do wrong? It's not arrival rate. It is the all arrival time. And all arrival time. Okay. Run again. Yeah. And it's running. We don't need to run many. Just maybe 100 is enough. Oh, A not defined. Who is A? Oh, we were trying to do something. We have the all arrival times. Just plot them then. ELT dot. Is it gonna be dot plot or dots? If we do plot, it should be star, right? This is the command. This is star. X is the arrival time, and Y is the. It should increase, isn't it? With the first one being range, 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 starting from 1 to what? To length of the all arrival time. Probably +1, I suppose. And then, but PLT not defined. Okay, import. Not PLT. Has no attribute stairs. So what is the command to plot? Stair or step? Maybe step. Maybe step. X, Y, and where equal to 3. This is step. Step and free plot not defined. Okay. Hopefully it's working. ELT.grid. Oh, so many. How come there's so many arrivals? Next customer only 10. Because we generate so many traffic. Floating. Okay. All right. The first arrival is y limit. Limit to 0 to 20. Set the x axis. X limit. How do we plot the step size? X tick. Is it X tick? X tick, maybe X tick. Not sure. One, two, three, four. Oh no. Oh, okay. So it's Y tick then. Y tick. And then boost. Okay, so you can see that. Oh, thank you. Range min x max x. Yeah, thank you. Is it pre or post? Is it pre or post? Have to check. Pre or post? The first arrival coming at 0.08. Yeah. Yeah. The first arrival coming from 0.6 is 1. This is 2, 2.5. Good, nah? But there's one missing here. One missing here. We need to set it to 0, right? How about adding 0? Does it work like this? Or 0 plus? Then the range. Is it like this? The first arrival. The first arrival is 047. No. 094. Yeah, 094. Huh? Yeah, this is a plot for the arrival. Yeah. You can do for the departure also. Yeah. You can do for the departure. And where is the departure? Are you okay with this? Shall I send you the file? Testing. Range. Yes. To 1. Yeah. Yeah, you can try the file. You should be able to do the homework. So I can do the departure. I think departure is also the departure. The departure time. Whenever there is a departure, when will there be a departure? When arrival, the departure. This is a departure. Yes, departure happen, and then it's the departure time. Oh, but departure from, oh, it's a departure from which server, isn't it? The departure from which server? Yes, the departure from for which server? Yes, for which server? This is a departure. Anywhere else, there might be a departure. Huh? Here? Or not? No. That when the event type and the event type, it has to be the event type. Oh no. Oh yes. The event type is what? Yes, yes. It is the event type. Now we know the correct or not time. The time next event and the event type. We append our departure time and arrival time. There is a departure here also. Oh, because it's the queue. It is the queue. So Is it oh. So it will be event type. Departures. Is it correct or not? There might be the, I mean, the departure time from one server may be maybe before another. I think this has to be careful. Yeah, I think this is a little. This is more tricky because you need to know which server it is departing from. I think if we put it this way, yeah, we can sort them. Yeah. But in the homework, it's more challenging. I do a simple version. So that's it. We have all the departure. How do we, let's say a equal to 1, 2, 3, 5, 3, 5, 4. Okay. Can I say dot sort? Can I say sort? Okay. Name sort not defined. Any commands to sort?
Sort it, Ajahn.
Huh?
Sort it. Sort with ed the last.
Oh, sort it. Okay. Yes, that's it. That's nice. So I can sort it. Yeah. Where do I plot? Yeah, this one we plot the arrival. Now we can plot the departure. Departure time and sort it, right? And length of, do I set the same as before? Prepend 0. What do you think? Okay, let's try. It is weird, isn't it? Huh? Yeah, not okay, eh? Because it jump by 2. Why is jumping by 2? Why they're jumping by a factor of 2? Okay. Not okay, no? It's weird. It's jumping by 2. Why is it jumping by 2? We have sorted all departures. Now let's see. Let's see. Print sorted by departure. Oh, we have 2 copies. Everything 2 copies. Why? Why everything has 2 copies? Here it looks like it has 2 copies. It means I append too often. Okay, when do we have to append the departure? here is means they are free server and server now busy, then we set them the departure time. Yes, we do not do anything in this. We do when the departure comes. The departure comes. The departure comes. So I should not add this one then, huh? Isn't it? Nah, we only have to handle when the oh, okay, or departure time. Or departure time is appended every time you see a departure event. Nah. And print all departure time. Why is it still repeating? Why they copy twice? Khan, any suggestion? They append seems to be 2 times. Now I am appending all departure time. Only, oh, here, no need, right? No need. We handle departure time as it comes. Okay. Yes. Sorry about that. Okay, so the difference between departure time and the arrival time will represent the time that, what is it? What is the time? No, with in our case is MM1. Is it MM1? Is MM1? No, we have to set to MM1. Is it MM1, right? Max capacity becomes a lot, you know, NE24, a lot of capacity. Float object, oh, sorry about that. So we are simulating MM1, right? Tan, are we doing MM1? ใช่ไหมเราทำ MM1 อยู่ถูกไหม Then we have to set the maximum capacity to a very big value. Okay. Okay then. Any question? If not, I can pass it to Noel to help you. Any question? Just leave on the line group or chat. Okay, right? You can now start your homework. And yeah. Okay, Noel, could you please take on your assignment? Yeah,
Yes.
Sharing.
Right. So every student will have to show me their homework. So who's going to be first?
Sir, good morning at first. I would like to tell you that I did the previous work which you have assigned, but I had a problem with the rendering, with the background, basically the image.
Right. Can you share your screen? Show me. I'll tell you
Yes,
what's wrong.
wait for a while.
John, I don't see Brian here.
Yeah, he is in.
Hmm?
Yeah, I'm here. Here.
Oh, it's got your student number. Sorry, Brian.
Okay. Okay.
Okay, can you share your screen and show me what the problem is?
So I keep the recording runs. Huh?
Yeah, no problem. Did you just check your line, John?
Oh, okay, can.
Your second line. I just sent you a video.
Sir, the image is still rendering, so it will take a little bit time.
Yeah, no problem. What's wrong with the background then? I can see the background. What's wrong with the background? What is the problem with your background? I cannot hear you.
Sir, sorry. Actually, sir, the background is very much blurred, sir. It's not clear as it should be.
It's not clear. Okay, what you can do is if you open up Blender, go to Blender.
Yes, sir.
Okay, now if you, let me just reduce this panel on the side. You see your icons on the right side of the screen. Icons, you got the camera and then 2 pieces of paper, the 3 squares. On the right side of the screen.
Yeah,
Go
right here.
up.
Yes, sir.
No, go up a bit, go up. And you want to do the background, the world, the 4th icon. Yeah, that one.
Yes,
Click. Did you click it? Okay, now go down to the bottom to the viewport and go to the viewport. But now press Shift Space. Shift Space to make it large. Okay. Now, if you look, it's on world background now. You've got it on world. Okay. What you can do is double the size of the background so it's smaller. So take the, you've got generate. Oh, you got generate. That should be okay. You can also change that to camera if you want. Okay, the texture coordinate, move it to the left. No, the texture coordinate. The texture coordinate node. The node, the first one. The first node.
Oh,
Yes, that
right
one.
here. Okay, sir.
Move that across to the left.
Right there,
Left.
sir.
Yeah, keep going, keep going, keep going, keep going. Keep going. More. Okay. Do Shift A. Shift A. And add converter. And you want to do, no, it's not converter. Vector, sorry, vector. Vector. And you got mapping. Oh, you've already got a mapping there. Okay, put that one on again, mapping. Okay, don't drop it, I'm just checking. You can delete it again now, delete. Okay, go to where it says scale on your mapping node, go to where it says scale.
Okay. Yes, sir.
Yeah. Why have you changed that?
I
It
was
should be just
adjusting the
one-
image, sir.
Just go 1, 1, 1 a minute. X1, Y1, Z1. 1, 1, 1. And then go shift space. Yeah, shift space to go back there. And then just do a quick render now. Yeah, that one. You have to render again.
Okay, sir.
Just go down to the white circle at the bottom. Oh, okay. You can just do a screen render, it's quicker. Yeah, that one there, render. At the top, top. No, render. Yeah, that one. This will render faster. If you go down a bit on the right side column, go down. On the right side column, where it says dimensions, metadata, output, right side, right. Right side. Do you see where it's, go down? Go down a bit. Right side of the screen. Right on the right side. Can you hear me?
Can you repeat again, sir? Your voice was not
Go
clear.
to the bottom right-hand side of your screen where it says output. Right side, not left. Right.
Okay, sir. Wait.
Right.
Yes, sir.
Right. Stop. Now scroll down a bit. Scroll down, and you go down. Scroll down. There. It says preview 32. See, change that to 16. PRE. Down. Stop. Go up a
On the
bit.
sample.
Samples.
Right.
Samples. PRE. Down.
Okay, yeah, right.
Yeah.
Yes.
Yeah, that one there. Change that to 16. And it'll render 60. Yeah. Now it'll render faster. Okay. Now your image is too big. So if you go to the scale now and do the scale. Yeah, that one. And do 50, 50, 50.
50 or 15, sir?
50. Yeah, and down and 50. And down and 50. Then shift space. Okay, now you need to move your image. Your image is upside down with the looks of it. Okay, on the rotation, rotate Y. Down the bottom of the screen, look. Down the bottom, you have it open there. Yeah. Change the Y to 90. Rotation, Y, 90. Yeah, enter. Now you got the clouds up there. Okay, your clouds are still a little bit on the big side. Change your scale to 100, 100, 100. Scale.
Which coordinate, sir?
Scale. Yes, 100,
Okay.
100, 100, X, Y, Z. Just let it render a bit. Is that better now? Is that clearer?
Yes, sir. The image is clear now, quite clear, much better than before.
If you want it bigger, you just put it to 200 or 300 or 500. Makes the image clearer.
Okay, sir.
Okay.
Thank you, sir.
No problem. You don't have any foreground lighting. All your lighting is coming from the HDRI. Because if you look at the shadow on the center bottle, and it's dark. You see it?
Yes, sir.
The third bottle, 1, 2, 3. The
Yes,
label
sir. I see
is
it, sir.
dark because you have no lighting at the front of the screen. Go to texture mode. texture mode. Yep, that one, texture. You got one light there. I can see the light. Press
Yes, sir.
7. Yeah, press 7. Okay, you got one light there. Zoom out a bit. You got one. Oh, this light over this side. Look, this one here. Click on that lamp. Right click, and go R to rotate.
Which one, sir? Kindly repeat.
R. Now, and take it back further. Take the line back further. No, not as far as that. Go back. Keep going back. Keep going. Bit more. Stop. There. It's fine. Click, and then press number 1 for front view. Number 1, and then number 5 to turn perspective off. Press number 3. Okay, you got that lamp there. Bring the whole picture to the center. Scroll left. Okay. That lamp is pointing down too much. So now do R again, rotate it up in the air a bit. Keep going up, but yeah, about there somewhere. Down a little bit. Yeah, about there. Click. And then press 0. And then zoom in. And then render it again now, see if the lighting looks better. Now it's lighter, you see? You can make it lighter more. It's because the bottle on the right is casting a shadow on the second bottle.
Yes, sir.
Yeah. But it's okay, it's perfect. Perfect. Very good.
Thank you, sir.
Okay. Next student, please. When you render this one completely render, can you please send a copy to a Jan Lungicorn of the finished render?
Sure, sir. I will send it on.
Okay, thank you. Who is next? Chuang? No, he's not here. Brian,
Yeah.
did you do the homework?
Not yet.
What? That was a week ago, Brian.
Ajahn just arrange the new like schedule for.
No, but I gave you
Sending-
homework last Friday.
I'm quite busy. This
I
week.
know, Brian, so am I, but I still do things for you.
Sorry, but I'm quite busy.
Mr. Chuang, is he here? He's not answering.
Maybe he's Tan or something. Tan, right?
Hello, Mr. Chuang.
Yes, but I have
Okay.
not done,
Can you show us your work, please?
I have not done just, sir,
You
because
haven't
Ajahn,
done it. Why?
Ajahn set the deadline for next week.
Yeah.
Ajahn, your students haven't done their homework.
No, he is very diligent student. I think he.
No, I mean Brian as well.
He's optimizing his time because
Oh,
some students requested for extension.
okay, until next Friday.
Yeah, kind of, yeah.
Okay. Mr. Natapom, have you done your homework? Natapom? Brian, can you ask him, please? Brian? Now
Yeah,
Brian's gone.
wait a sec.
Thank you. Can you ask Mr. Natapom if he's done his homework? Nobody's answering.
น่าจะไม่มีใครอยู่แล้ว
He's got a red icon. Natapom Chalunwuttanom.